Switch over to Charles' law, and you can see in Charles' law, pressure is fixed, and you can change volume and temperature. So the first thing we're going to do is, again, we're starting now at 298 Kelvin and a volume of 3, pressure is being held constant at 1. And they ask us to increase the temperature, and what do you think is going to happen? So down here is the temperature control. I'm going to increase that. It says go up to 443. You can go to whatever you want. 443, sure. I went too far. 443. And then what happened to the molecules? Did you see what was happening to the molecules while we were doing that? If you didn't, let's go back down to room temperature, and you can see that again. And then watch that. So just, oh, look, you can even see they're kind of moving a little bit slow. They're hitting each other. But then when I increase the temperature, also notice what's happening to the volume of the container. When I increase the temperature, it looks like the volume is also going up, which makes sense because now these molecules have more energy. They're moving around faster, and they're going to push the sides of the containers. They're going to push that piston up if the pressure is being held constant. So I can calculate that, and they want you to do that on the data sheet. Let me pull up my data sheet really quick. There we go. Right, so I kind of answered that for you already. Record your observations, what's happening, what happens to them, what happens to the behavior of the particles, and then how do I find that new volume? So what is Charles' law? What is the equation for Charles' law? I have V over T is V over T. Oh, doing it purple this time. I've got V over T equals V over T. So V1 over T1 equals V2 over T2. And in this problem, we have a V1, a T1, and a T2. So we're solving for V2. So I want to solve for this V2. So I can plug everything in. I've got volume of 3 liters. My T1 is 298. And over here I have V2 that I'm looking for. And here I have 443. If you're looking at that and having like flashbacks of 5th grade with fractions and decimals and this is crazy, don't worry, it's not that bad. We're trying to isolate that V2, so we're just going to multiply both sides by 443. 443, and when you work that out, you should get the same answer that you get that the system gives you. So this is a good way to check your math right over here. So I got 4.46, and I think I got that when I did the math on my own too. So 4.46. 4.46, sorry for the messy writing. All right, and then we want to reset. So, well, what did we notice? What did we just notice when we did that? You can visually see it when we increase the temperature, the volume also increased. So volume and temperature, if I plotted volume versus temperature, you can see they're increasing. If one goes up, the other one goes up, right? So if I increase in temperature, then I'm going to increase in volume. Increase in temperature, increase in volume. That's what we should see happening here. So I'm going to reset up there with my reset button. And then down here, this time they want you to change the volume. So use the volume controls to reduce the volume. All right, so what happens if I reduce the volume? Right now I'm at 3. I'm going to go down to 1.9. 1.9. You can see what happened. It went down, and the temperature also went down. So I can calculate that. It's giving it to me right there. So if I wanted to solve for that, which is good, you want to practice. Oh yeah, also observe what happened to the molecules. They're moving a little bit slower at a lower temperature. But again, we want to do V over T equals V over T. But this time, we were solving for T2, right? So I gave you the answer already, but we're going to confirm that that's true. So I had volume 1 was 3, and T1 was 298. And then in this case, we gave you a new volume, 1.9, and we want to solve for T2. Right, so these are our 1s and these are our 2s. So how do we solve for something on the bottom here? You can cross multiply. Do you guys remember cross multiply? So that means I bring this T2 over here. I can bring this guy over here. So I end up with something like 3.0 times T2 equals 1.9 times 298. And then I can divide by 3.0. Divide by 3.0. And when you do that, you should end up with a 1.89. Sorry, 189, not 1.89. 189. Right, so 1.9 times 298 divided by 3 should give you exactly what the program gave you. So that's just a little bit on the math on how to solve for that bottom equation. I know sometimes that gets a little bit tricky. So the next thing, go back up. And now just like we did before, right? So each one of these laws where we change the one variable, measure the other, then change the other variable, and then measure the other one, and then we're gonna do like 4 more trials of changing one and measuring the other. So the procedure will tell you exactly what what to do here. So you reset this, and then we're going to go to these other temperatures. So they're going to tell you, okay, you're starting at 298, then you're going to go to 353, then 403, then 473, and then find all the volumes for those. I'm going to do the example with slightly different numbers so that, again, I'm not giving away all the answers. So we had 298. So now we're changing the temperature. So I'm over here changing the temperature. These are the ones that I did. So I did, instead of 353, I did 343, and so you're just going to do that, add your data, and then it'll automatically calculate that one for you, and then do 398 or whatever the next one is, add data, change your temperature, add your data, change your temperature. Come on. Was a big one. Calculate. So in each case, you can see as I'm increasing the temperature, I went from 298 to 3 to 3 to 398 to 463 to 598. The volume is also increasing, or you can see it in the graph. As I increase the temperature, I increase the volume, increase the temperature, increase the volume. So you're going to get that straight line. That's great. Now we're going to graph this with your data. So you're going to make the same graph, but you're going to get the trend line as well. So copy. So I left click, right click on this to copy. Open up my Excel. I just added a new sheet over here. So this was all our Boyle's Law data. This is going to be our Charles Law. So paste that. Great. So I just pasted it. You guys are going to be experts in Excel. So you can either highlight this column, then highlight this column, or you could just highlight both of them. Both should work. And then you're going to go to Insert, Graph, XY Scatter. Great. And then you want to confirm that things are on the right place. So you want volume over here. So I want volume on my, I'm going to plus that, go to the plus sign, add your axis titles, 3, and then I'm looking at the volume. I'm just checking this. I've got 3, then I've got 3.5, 4, blah, 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 increasing, keeping going there. And then temperatures on the bottom. So I've got my volume over here, which is what I wanted to do. And then I have my temperature down here. Right, so I changed the temperature and then I measured the volume. That's how I did this one, right? I changed the temperature, then I measured the volume. So the volume is depending on whatever I change the temperature to be. All right, so I also want to then, let's call this one Charles' Law. Charles's Law. Charles' Law. If I wanted to add a trend line, I left click, then I right click on this and add my trend line and then display my equation on the chart. Boom. And then there's just a couple other questions to answer after that. So you can kind of walk through those questions. Gotta hope that these Excel tables are getting a little bit easier.